These are the frequently asked questions for Algebra 2 for section 6.6 day 2, where we are learning about composition. Starting with number 29, we have h of g of -2. So my h is x squared plus 4, and my g is 2x. And h of g of x is telling me that I need to go to h, and wherever I see an x value, I need to replace it with the g of x function, which is 2x. So here's my x. I need to replace that with 2x. So that will give me 2x, the quantity squared, plus 4, which will be 4x squared plus 4. And then what I need to do is I need to put -2 in for x. So that'll be 4 times -2 squared plus 4. And that will be 4 times 4, because -2 squared is 4, and we're following the order of operations. And that will give me 16 plus 4, which is 20. So the answer for number 29 is going to be 20. And just like I was talking about in class, it's always helpful to go ahead and write the functions down in the order that you see them, so that it'll help you visually put that function in to the other function. And that's the part of composition we need to get used to. 37 wants f of g, so I'm going to write down f first, and f of x is just x squared. And then I have g of x, which is x minus 3. And the composition tells me that x minus 3 needs to go right there for x. And that, of course, will give me x minus 3 times x minus 3, a binomial squared, which is x squared minus 6x plus 9 as a perfect square trinomial. And then I need to put a -2 in. So -2 minus 6 times -2 plus 9. So this will be -2 plus 18 plus 9. -2 plus 18 is 16, and 16 plus 9 is 25. So once we evaluate for the number that they give us, we're just following the order of operations. That's all we're doing. Then in number 43, this one has us do g of f of x. So I'm going to write down my g function first, then my f function, and again, do my composition, which is just a fancy word for substitution. So that's going to be x squared minus 3 when I substitute x squared in for x. And now they want me to put a -a into this formula. Well, a negative squared is just going to be positive, so this will be a squared minus 3, and that will be my final answer. So at that time, not a numerical value that we're evaluating for, but just another variable to see if we can handle using those inside our composition formulas. Number 45, we have sales. And it says a computer store offers a 5% discount off the list price X for any computer bought with cash, rather than put on credit. At the same time, the manufacturer offers a $200 rebate for each purchase of a computer. A is write a function f of x to represent the price after the cash discount. All right, so they've got your computer store offering a 5% discount off the list price of X. So the price was X, but they're going to take 5% off of that price. So we're really going to have x minus 0.05x, which is 1x minus 0.05x, which of course would simplify to 95% of the cost, which makes absolute sense when you think about, hey, if I'm not paying 5%, I am paying the other 95%. And then B says, write a function g of x to represent the price after the $200 rebate. Well, a $200 rebate is just going to come from the original price minus $200. And there's no simplifying that we can do there. That's just going to be x minus 200. Now, C says, suppose the list price of the computer is $1,500. Use a composite function to find the price of the computer if the discount is applied before the rebate. So what I want to do is go back and just kind of label A as discount and label B as rebate. And then you think, well, what are they asking me to do? They're asking me to put an order into this. And whenever we work with parentheses in math, the innermost parentheses are the first operation that we take care of. So in C, if it says we want the price of the computer if the discount is applied first, that means we're going to take x minus 0.05x, and we're going to put that into the other function. And the other function was that rebate. So what we want to do here is have the rebate function and the discount function working together. But the price of the computer if the discount is applied before the rebate. So what they're going to do is they're going to take the discount, and then whatever they get, they're going to subtract $200 from it. Well, this of course was our 0.95x minus the $200 because you have the discount first and then the rebate. And I don't know if they want us, let me take a peek here. They just want us to find the price. They don't care if we label it another function or not. We could call this h of x if we want to. But what they really want us to do is just use that, put the $1,500 in and see what happens. So 0.95 times the 1,500, and then subtracting the 200 is $1,225. And then the next one, you can already kind of feel, hey, they're going to have us do it the other way so that we can see which one is going to be the best for the consumer. Suppose the list price of the computer is $1,500. Use a composite function to find the price of the computer if the rebate is applied before the discount. So if we're going to do rebate first, then discount, well, we can take our rebate and put it into our composition, make our composition function into that discount formula. So it will be 0.95 of x minus 200. And we could distribute that, but again, they're not asking us to call this another composite function at this point. So I'm just going to call this g of x, and we can absolutely just put the 1,500 in here and follow the order of operations. So 1,500 minus 200 is 1,300, so 0.95 times 1,300 will give us $1,235. So the better deal is definitely through C, and that would be they're going to do the 95% cost first, so the 5% discount, and then subtract the $200 from the cost. Then number 53, we are supposed to find a negative f of x plus 4 times g of x. And this one just usually drives people crazy because of the notation. It's not that the math is really hard, but we need the negative of the whole function, f of x, and then we're going to add 4 of the g of x's, and again, that is the entire function. So we have to make sure we do some distributing on this one so that we don't miss anything. And this will be negative 2x minus 5 plus 4x squared minus 12x plus 8. And then we would go ahead and combine like terms that we can. So we have 4x squared minus 2x minus 12x would be minus 14x, and then minus 5 plus 8 would be plus 3. And again, just checking to see if they want you to put a label on it. Nope, no labels, so no g of x, h of x, or anything like that. Now I go back and I think about the domain and the range for these from the very start. And I'm using f of x and g of x way back up here at the top. And there are no restrictions on the domain there. I don't see any even roots and I don't see any division, so it would be all reals at that point. And then I look through each step as I've worked through this problem just to see, while we were doing the problem, if at any point we introduced division or any even roots. And the realization is, no, we didn't do any of that. So the domain for this function is going to be all real numbers. We did nothing there to introduce any restrictions on the domain. 57, you can already see, we're going to have an issue with the domain on 57 just because it is division. So we are to put f of x, 2x plus 5, over g of x, which is x squared, minus 3x plus 2. Now, because I know I have the division, the first thing that I'm going to do is I am going to factor that denominator so I can find out what my restrictions on my domain will be while it's still in this division form. So we need two numbers that multiply to positive 2 and add to negative 3, and that will be negative 2 and negative 1. So my domain restriction is going to be that x cannot be 2 and x cannot be 1. Now, the other thing I was checking for is, can I cancel? Remember, canceling is a form of division, and in order to use division, you have to see pure multiplication. This is not pure multiplication up here in my numerator. That has addition taking place. And if I do not have a perfect match for that as one of my factors in my denominator, then I can't cancel it out, and I can't. There is nothing I can do here. So this says, hey, I tried it, nothing is working, but it did show me my domain. We might as well just leave it. 2x plus 5 over x squared minus 3x plus 2. And our domain, x cannot equal 2, x cannot equal 1. Any other real number will work in that case, but we just cannot use the 2 that would have us dividing by 0. 59. A craftsman makes and sells violins. The function I of x equals 5,995x represents the income in dollars from selling x violins. The function p of y equals y minus 100,000 represents his profit in dollars if he makes an income of y dollars. What is the profit from selling 30 violins? So what's going on here is this person, this craftsman, is selling violins right there. And they're selling them at $5,995 each. But they do have costs, and the costs are $100,000. So whenever you figure out how much you've made from your income, you have to subtract $100,000. Well, that would mean for a composite function, I would have to take 5,995 times x to figure out how much income this person has, but then I'm going to subtract that $100,000. So it says, what's the profit from selling 30 violins? We are doing a composition. We're saying, let's put this in for y in order to figure this out. And then it would just be a matter of grabbing a calculator and finding that. So 5,995 times 30 for selling 30 violins minus $100,000. And that is $79,850. Right there. All right, next one up, 61. A salesperson earns a 3% discount on weekly sales over $5,000. Consider the following functions. G of x equals 0.03x and h of x equals x minus 5,000. So right away I'm looking at these and saying, well, which one is which? Well, here's the bonus right here, because it's 3% of the weekly sales. So x would stand for the weekly sales. And it says it's the bonus on weekly sales over $5,000. So this would be the amount used for the bonus. Because the first thing you would have to do is take your sales, subtract 5,000, and then you could take whatever you have left over times that 3% bonus. So A is explaining what each function above represents. G of x is the amount of the bonus. And h of x is the income that is used to calculate the bonus. because the sales have to be over $5,000. They subtract 5,000 and whatever's left was above that 5,000. And then B says, which composition, H of G of X or G of H of X, represents the weekly bonus? Well, like I said, the business is going to take this X minus 5,000 to figure out how much money is used for the bonus, and then they're going to calculate that 0.03. So that means the H of X is the innermost piece. It's the piece that's being substituted, composited into the other function. So it would be G of H of X that would represent that weekly bonus. And then the explain part is just what I was talking about here. How do you know which one is which? Well, we would pick this one because they would first need to figure out the amount of sales eligible for the bonus. Before calculating the bonus. So it just makes sense. What's eligible for the bonus? Now take 3%. That will get you the bonus. 62 says if f of g of x is x squared minus 6x plus 8 and g of x is x minus 3, what was f of x? And I notice they had to take g of x and put it into f of x. So they had this x minus 3 and they put it into some function and magically got this. Well, it's not magic because I notice that the x term is squared. So what that means is they squared that x minus 3 and then they did something to it to get x squared minus 6x plus 8. Now how do I know that? Because x minus 3 times x minus 3 is x squared minus 6x plus 9. So you sit and think, how did they get that 8 to be an 8? Well, they subtracted 1. That's all they did. So they squared it, and then they subtracted 1. So f of x equals x squared minus 1. So all you do is kind of work backwards as to how these numbers came to be in the positions that they are in. Then we have a g of x and an f of x here, and we are to do some compositions and then evaluate for a certain number. 63 has f of g of 1. So that means if I have f of x, x minus 2 over 3, I am to put g of x, which is 3x plus 2, in for x wherever I see it, and that would be right there. So this will be 3x plus 2 minus 2 over 3 when you do the composition. Well, the 2's are going to drop out, and the 3's are going to cancel, and you get x. So if they want me to put a 1 in there, 1 is just going to be 1. That's it. So that's the answer. So kind of an interesting little composition going on in number 63. And then 64 has you do that in reverse. G of f, and then evaluated numbers. So G was 3x plus 2, and f was x minus 2 over 3. Well, what I'm supposed to do is take this function, and wherever I see an x in the first function, replace it. So that will be 3 times x minus 2 over 3 plus 2. And I notice my 3's are going to cancel out, and I'm going to get x minus 2 plus 2, and I just get x. So it says find g of f of negative 4. Well, if I put a negative 4 in there, I'm getting negative 4. Right there. And you'll notice for number 63 and 64, no matter which way we do this, as f of g or g of f, the composition works the same way in both directions. Remember, that does not always happen. So you do need to do each of these problems individually to check that out. All right, 67 has us do g of x. Well, g is 3x plus 2. G is 3x plus 2. Wherever I see an x, I'm going to replace it with 3x plus 2. So 3 times 3x plus 2, which is going to give me 9x plus 6 plus 2, which is 9x plus 8. And they wanted me to evaluate this for x equals 0. Well, 9 times 0 plus 8 is going to give me 8. And there it is. That was number 67. I do have one more that I wanted to go over with you here. Oh, two of them actually. It says for each pair of functions, find f of g of x and g of f of x. So this is where we really want to see that sometimes they don't come out to be the same thing for f of g of x and g of f of x. So f of g of x means I'm going to take the 3x, and wherever I see an x, I'm going to replace it with x squared. So f of g of x is going to equal 3x squared. Then I need to do g of f of x. Well, that means I have g of x, and wherever I see an x, I'm supposed to replace it with 3x. Well, that will be 3x, the quantity squared, which is 9x squared. And right away, we see that those two answers are not going to come out to be the same thing. And that's the point of these two problems, is to show you, it just does not work forwards and backwards always. Then, 473, f of g of x. Well, we have f of x is x plus 3. We have g of x is x minus 5. Wherever I see an x in the first one, I'm going to replace it. That will make it x minus 5 plus 3, which is x minus 2. And then g of f of x. Well, g of x is x minus 5. F of x is x plus 3. Wherever I see an x in g of x, I am to replace it with x plus 3. So x plus 3 minus 5, and that will give me x minus 2. So one example here of where f of g of x and g of f of x do not come out to be the same, and then an example where they do come out to be the same, just so that you can see that each one of them needs to be checked.